So now we'll move on to the next part of this chapter, that is mode. So already we have studied at what is mode and how to find out the mode. Mode is actually the maximum frequency of the given data. That is whatever data is given, the observation which has maximum frequency or the observation which is occurring most number of times is actually the mode of all the observations given. So whenever the observations are given, we actually need to see, or we actually need to find out which observation has the maximum frequency. So that observation will become the mode of all the given data. So like suppose if we take any example, like suppose if we take example 120, 110, 130, 110, 110, 150, 120 and 110. Now if we see that there are 8 observations, 1 2 3 4 5 6 7 8 observations are there, and and there are some different observations, and some observations are repeating. So actually we need to find out that which observation is repeating how many times. Like suppose if we take 120 as the first observation is 120, so 120 is repeating 2 times. It means frequency of 120 is 2. In the same way 110, 110 if we see, so 110 is repeating 4 times. In the same way next observation 130, 130 is repeating 1 time only, and 150 is occurring 1 time only. So it means the observation which is equal to 110 is occurring maximum number of times, or it is having the maximum frequency. So therefore mode of all the observations is of this all these observations is equal to 110, because 110 is having the highest frequency or the maximum frequency. So the observation which is having maximum frequency is will actually become the mode of all the given observations. So this is the way to find out the mode. Now we see one more example based on this. Let's first write down the example. Find x if mode is 25. So accordingly some observations are given, and for among these observations there is one missing observation, that is x. So accordingly we need to find out the value of x when the mode of all these observations are given as 25. 15, 18, then 16, 20, 25, again 20, x and 18. So now accordingly we'll see which observation is repeating how many times. First observation is 15. So we'll see 15 is repeating how many times. 15 1 times, 2 times and 3 times. 15 is repeating 3 times. So frequency is 3. The same way next observation is 20. So accordingly we'll see 20 is repeating how many times. 1 time, then accordingly 2 time and then 3 time. So 20 is also repeating 3 times. Next observation is 25. So accordingly we will see 25 is repeating how many times? 1 time, 2 time, 3 time. 25 is also repeating 3 times. Next observation is 18. So accordingly we will see 18 is repeating how many times? 1 time, 2 time and 3 time. So 18 is also repeating 3 times. Next observation is 14. 14 is repeating only 1 time. 14 is repeating only 1 time. Next observation is 16, and 16 is also repeating only 1 time. So now as we have seen that as we have find out which observation is repeating how many times, but for all these observations mode is given as 25. It means why mode is given as 25? Because among these observations 25 is repeating maximum number of times. But if we see among all these observations 25 is repeating 3 times, and there are other 3 observations, that is 15, 15, 20 and 18, which are also repeating 3 times. It means that 25 should have the maximum frequency if the mode is 25. So that's why the value of x among all these should be 25. Should be 25, because 25 if the mode is 25, it means the 25 has the maximum frequency. And if we consider this 15, 20, 18 and 25 all are having the same frequency, so definitely x will be 25 in that case to have the maximum frequency. So in that case if we take x as 25, the frequency of 25 will become 4. So as frequency of 25 is highest, so or the maximum frequency, so that 25 will become the mode of all these observations. So definitely the value of x should be 25. So in this way we need to solve the question based on the mode. But this in this question we have seen that there are random data is given. So if the random data is given, then we can easily find out the mode. Or if the discrete frequency distribution table is given, then also we can easily find out the mode, because in the discrete frequency distribution table, observations are given with the frequencies. So the observation which is having the highest frequency, that will become the mode. So it is easy to find out the mode in case of discrete frequency distribution table. But if the continuous frequency distribution table is given, continuous frequency distribution table. So if the continuous frequency distribution table is given, continuous frequency distribution table means class intervals with the frequencies are given. So if the class intervals with the frequencies are given, then how to find out the mode is, then the method to find out the mode is, there is a formula, that is L plus F1 minus F2 upon 2F1 minus F0 minus F2 into H. So this is the method to find out the mode in case of continuous frequency distribution table. Here L is actually the lower limit of modal class. Now what is modal class is? Modal class is the class which is having the highest frequency. So the class which is having the highest frequency is considered to be as the modal class. So L should be the lower limit of the modal class. F1 should be the frequency of modal class. So whatever will be the frequency of modal class, that will become F1. F2 is actually the frequency of class succeeding the modal class. So it means F2 is actually the frequency of the class which is after the modal class. So whatever class is there after the modal class, frequency of that class will become the F2. F0 is actually the frequencies of class preceding the modal class. So F0 is actually become the frequencies of the class preceding the modal class, and as H is equal to class size of modal class. So in this, as we have seen, that everything depends on the modal class. So definitely first we need to find out the modal class, then accordingly we can easily find out the mode of the data given. So accordingly we'll understand this, how to find out the mode with the help of example. First accordingly we'll write down the example as class intervals and frequency. So accordingly first we write down the class interval and frequency, that is 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, and 60 to 70. So accordingly we have taken this as class intervals, and accordingly frequencies are 5, 8, 7, 12, 28, 20, 10. So accordingly this we have taken frequencies. Now if we need to find out the mode in this case, what we need to do is, first we actually need to find out the modal class. So modal class in this case will be 40 to 50, because 40 to 50 is the class which is having the highest frequency, that is 28. So that's why this becomes the modal class. So modal class is the class having the highest frequency. Now the formula is L plus F1 minus F0 divided by F1 minus F2 divided by 2F1 minus F0 minus F2 into H. So accordingly what we need to do is, we need to find out the value of all these things. That is, value of L is actually the lower limit of the modal class, and lower limit of the modal class is 40. So L will become 40 plus F1. f1 is actually the frequency of the modal class, so that will become 28 minus, as the frequency of modal class is 28, that's why f1 is 28 minus f2. f2 is actually the frequency of the class succeeding the modal class, that is frequency of the class which is just after the modal class. So frequency of that class is 20, that is f2 will become 20 divided by 2f1. 2 into f1 is 28 minus f0. f0 is the frequency of the class which is just above the modal class, that is 12. So that's why f0 is 12 minus f2. f2 is 20 into class size of modal class, that is class size is upper limit minus lower limit, that is 50 minus 40, 10. So that will become h. Now accordingly, if we solve it, that is 40 plus, so this will become 8 divided by 2 into 28 will become 56, and 56 minus 32 will become 24 into 10. So now accordingly, if we solve, what we'll get is, we cancel out this thing, so it will become 40 plus 10 upon 3. So that will become 40 plus 3.33 or 43.33. So this is actually the mode of the data given. So in this way we need to find out the mode. So this is the method to find out the mode. So whenever the continuous frequency distribution table is given, we actually need to find out the mode using this formula or this method. Now accordingly, we see the relationship between mode, median and mean. And the relationship between mode, median and mean is, mode is actually equal to 3 times of median minus 2 times of mean. So that is, if we need to, if two things are given, that is mode or median are given, we can easily find out mean. If median and mean is given, we can easily find out mode. So this is a relationship between mode, mean and median. And whenever we need to find out one thing, definitely we need to know the two other things. It means if we need to find out the mode, we should know the value of mean and median. And if we need to find out the median, we know the value of mode and mean. So in this way we can find out the value of mean, median and mode using this relationship. If two of these things are given, then we can easily find out the third thing. So this is the relationship between mean, median and mode.